we pose the question, is d big T d little t, the rate of temperature change with respect to time, proportional to T minus T sub r, the temperature difference, the difference between washer temperature and room temperature? If it is proportional to T minus Tr, then we'll have a certain kind of equation that relates these two quantities. So the question is, would we expect it to be proportional? There's some discussion in the page that goes with these video clips, and you should read that thoroughly. It'll amplify the discussion. But the answer to this question is, well, maybe. We would have to test this experimentally to see if it really is so. And we'd have to test it theoretically to see if it's consistent with other theoretical ideas that we might have. However, if it is, okay, if d big T d little t is proportional to T minus Tr, well, what does it mean for one quantity to be proportional to another? It means that first quantity is K times the second. That's how we write a direct proportionality, and that's what we're hypothesizing here. So if we have a direct proportionality, this is what we get. We remember that T sub r is our 80 degrees Fahrenheit. It can be expressed as 80 degrees or 80 Fahrenheit. I think I express it both ways in the materials that go with this clip. We could even, from the information that we've hypothesized from our imaginary data, say that if the rate is negative 2 degrees per second when the temperature is 150 degrees, remember we calculated that based on the idea that the temperature went from 160 to 140 in 10 seconds at negative 2 degrees per second, and that the midpoint temperature where we're going to, the approximate temperature at which we associate, or with which we associate this rate, is going to occur at 150 degrees, then we can easily solve this equation for K. The temperature difference at 150 degrees is 150 minus 80 degrees, or 70 degrees, and dt is negative 2 degrees per second. So K is going to be this divided by this, negative 2 degrees per second divided by 70 degrees, or negative 0.02757 degrees per second per degree. Now really we've gone overboard with significant figures here. We really maybe ought to call that negative 0.028, as I do in the materials from which you can run this program. Now we're going to see the implications of this in the next clip.